Hi, how are you? My name is Samuel, and through this video, I want to disseminate the innovations developed to optimize processes with drilling fluids. In this opportunity, we are going to talk about the advantages of using liquid lost circulation materials in drilling operations. When an undesired event occurs, such as a loss of fluid or to assist in the stabilization of poorly consolidated walls, which hinders the progress of drilling, where liquid loss of circulation materials can be a technical and economic option. An important factor in fluid loss control is related to response time. In this sense, the traditional LCM need to be added in a volume of fluid to later be able to move them through the perforation pipe and position it as close as possible to the loss zone. The time required to prepare the LCM batch may require several hours for its preparation. On the other hand, the incorporation of high concentrations of solid LCM directly affects the dynamic characteristics of the fluid, which eventually increase the risk of increasing the loss due to the increase in pressure in the annular space. In liquid LCM, the solid load is properly wetted, so its incorporation into the inverse emulsion fluid does not negatively affect electrical stability. As can be seen in the table, the original rheological values of the fluid do not increase with the addition of liquid LCM. In this case, the decrease in the yield point value is due to the fact that the liquid LCM contains in its formulation a proportion of dispersant that contributes to the suspension of solid particles in the suspension vehicle. However, when adding the same concentration of LCM, this time solid, the rheological properties of the fluid increase the values of the gels and the yield point, decreasing the electrical stability. In graph, we can observe the rheological behavior of the fluid, comparing the original condition in blue with respect to the sample that was added solid LCM in gray, or with the one that was treated with liquid LCM in red. Also, the ease of adding the product to the drilling fluid can be appreciated. An advantage of working with liquid LCM is its versatility compared to traditional LCM. They can be quickly added to the fluid, allowing to generation of batches with high concentrations of LCM in a fraction of the time. On the other hand, it does not generate waste as a result of its application, which implies an optimization in logistics and a reduction in the cost of final disposal. Liquid LCM are manufactured in 3 different particle sizes. Ultrafine. It is recommended for stabilization of areas of weak sand that hinder the progress of drilling. The LCM load present in the product is 700 kilograms of LCM per cubic meter of product. Fine. For wall reinforcement applications in formations. Made up of limos between 0.0054 and 0.074 millimeters, with little presence of cementing material. It can be used from 4 to 8 kilograms per cubic meter to control the invasion of fluids into the formation or to help reduce the dispersion of clays. To control fluid losses of up to 2 cubic meters per hour, it is recommended to apply to the system in concentrations of between 30 to 50 kilograms per cubic meter. The LCM load in the product is 700 kilograms per cubic meter of additive. Medium. For formations made up of fine sands between 0.074 and 0.42 millimeters, with the presence of cementing material helping to reduce the dispersion of clays. It can be used from 6 to 8 kilograms per cubic meter to control the invasion of fluids into the formation. To control fluid losses greater than 2 cubic meters per hour, it is recommended to apply to the system concentrations between 40 to 50 kilograms per cubic meter. The LCM load in the product is 500 kilograms per cubic meter of additive. The versatility of liquid LCM compared to traditional LCM allows them to be added quickly, facilitating the work to generate batches with high concentrations of LCM in a fraction of the time. On the other hand, the particles that are wetted previously improve their mobility, facilitating the formation curing process in static conditions. Additionally, during the operative processes, the risks of overpressure the formation are reduced due to the thixotropy provided by the solid LCM. the application of liquid LCM can reach to represent a saving greater than 10% compared to works carried out with traditional LCM. Finally, you can see a comparison of adding LCM to an inverted emulsion fluid. In both cases, an equivalent to 300 kilograms per cubic meter is added. In this video, we can see how a sample of solid LCM, equivalent to 300 kilos per cubic meter, is incorporated into an inverse emulsion fluid. In this second video, you can see how a sample of liquid LCM is incorporated into the invert emulsion fluid, also equivalent to 300 kilos per cubic meter. We hope this talk has been of interest to you. Thank you very much for your time. Keep having a great day.